Now we're ready for quadratic functions and their graphs. I know this seems strange because we've already looked at parabolic functions earlier in the course in analytical geometry in conic sections, and they were very detailed and stuff. Now we're going back to functions. And so you've probably seen this before in college algebra, so this should not be very hard for you at all. First, I want to go back to the vertex form. This is the vertex form of a quadratic function. If you look at the basic graph x squared and imagine that it's got a horizontal shift and a vertical shift and maybe a stretch or compression, A. The vertex is going to get shifted. This is horizontal, opposite of what it looks like, H, and vertical is what it appears to be. So this is the vertex form, and the vertex is always easy to spot. The vertex is HK, opposite of what it looks like, exactly what it looks like. If this coefficient right here is positive, then your parabola is facing up, and if it's negative, it's facing down. When I ask you to sketch these, and I want to emphasize the word sketch, you don't have to make it super narrow or super wide. You don't have to be super accurate with that, as long as it's facing the right direction. That's more what I'm after in this case. So here we go. You have 4 graphs on here and a set of instructions that we're supposed to do. So here's the first graph I'd like us to do. What we're supposed to do is find the vertex, the domain and range, the equation of the axis of symmetry, the largest open interval, where it's increasing, where is it decreasing, and say whether if there's a max or a min value and what it is. Okay, so the first equation I'm giving us, number 1, for the first graph is f of x is negative x plus 4 squared plus 2. Okay, this is in vertex form, so that's lovely. Okay, so the vertex is going to be opposite of what that appears and exactly what the k appears to be, negative 4, 2. A is negative, so it's going to be facing down. So our sketch is going to look like this. Negative 1, 2, 3, 4, up 1, 2. So here's our vertex, and it's going to be facing down, and this is a perfect sketch. That's all I need. So label the vertex, okay. What is the domain of this? Once we have it graphed, it's easy to see. The domain is going to be negative infinity to positive infinity. The range is going to be as low as it wants to go, negative infinity, all the way up here to the vertex, which is at negative 4, 2. So all the way to 2, and put a bracket on that 2 because it's included. Write the equation of the axis of symmetry. Now that is this axis. This is this line that cuts through the center of your vertex. And because your parabola will be symmetric about both the sides of that, so that the axis of symmetry, or the line of symmetry, is x equals to negative 4. This is the axis or line of symmetry. All right. Where is this guy increasing? He is increasing from negative infinity all the way up to negative 4. Where is he decreasing? He is decreasing starting at x is negative 4. Oops, negative 4 to infinity. All right. Is there a max or a min? There is a max, and the value of the max, which is a y value, it has a max of 2. If it ever asks you where is the max occurring, that's an x answer, and you say it occurs at 4. But the max value is 2. All right, that is that one. The second one I want us to do is this one. Y is x minus 3 squared plus 2. All right, let's find the vertex. This one is in vertex form, so the vertex is going to be 3, opposite of what it appears to be, 2, what it appears to be. A, which we didn't see, is 1, which is positive. This is going to be facing up. So I go over here to 1, 2, 3, up 1, 2, put my point, and then my parabola is facing up. Okay, this is the point 3, 2. Okay, so we said, what's the vertex? Is it facing up? what is the line of symmetry? Let's go ahead and put that in there. Well, it's going to cut through the vertex, and it's x equals to 3 is the axis or the line of symmetry. I will ask for the equation. So write x equals, not just 3, or axis equals 3. That's not good. X equals to 3 is what I want to see. Symmetry, okay. Let's see. What's the domain? Negative infinity to positive infinity. What is the range? Well, the lowest point we get to is 2. It goes all the way up to infinity. Where's this guy increasing? And where is he decreasing? He's increasing starting at 3. He's going up. So it's increasing from 3 to infinity. Where's this decreasing? From negative infinity to x is 3. All right. And then what else do we have to answer? Oh, is there a max or a min? Oh, there's a min, a low point. There's a min. What's his value? There is a min value of, that's a y, of 2. That's our answer right there. All right, here's 2 more. This is the equation I want us to look at here. F of x is equal to x squared minus 4x plus 1. Okay, the difficulty with this one is it's not in vertex form. So you saw that if you know basically where the vertex is and whether it's facing up or down, you can answer all those questions, no problem. So I don't know. So we've got a couple of options. We could get this into this form by completing the square method, and you all know how to do that. There's another way you can do it though. You can memorize one thing, and that's you've already got in your head probably x. This is the quadratic formula we just got through talking about. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you see this part? Not the discriminant, but this other part? That is the h coordinate, this h coordinate of your vertex. So h is negative b over 2a. Where's my b and a? Oh, this is b and this is a. So you can just calculate it that way if you want to. I'm going to do it that way. H, in this case, is negative 4 over 2 times a, which is 1. So this is 4 over 2, so this is 2. So I have half of my vertex taken care of. How will I find k? Well, the y value is the y value that goes with this x value too. So I just plug this 2 into the function. F of 2 is what's going to give me the k. So let's figure out what that should be. F of 2 is going to be 2 squared minus 4 times 2 plus 1. This is 4 minus 8 plus 1. Negative 4 plus 1. Negative 3. That is what k is. That's my vertex. So we found the vertex. This a in front of the x squared is the same a as this. It's the same one. So if this is positive, it's facing up, and it is. So let's go over here. 2, 1, 2, negative 3, negative 1, negative 2, negative 3. We're right here, right? And so we should be facing up. Okay, here is the line of symmetry, and the equation is x equals to 2. What's the domain? Negative infinity to positive infinity. What is the range? Well, the lowest point is right here at the vertex, so we're at negative 3 bracket, negative 3 to infinity. Let's see. Where is this guy increasing? He is increasing from this point on, so from x is 2 to infinity. Where is he decreasing? He is decreasing from negative infinity to 2. All right, what else? Axis of symmetry, increase, decrease, domain, range. Oh, max or min. This has a min value of negative 3. The value is a y, it's at negative 3. It occurs at x is 2, but the min value is y is negative 3. All right, let's do this last one on the front page. And so we have f of x is negative x squared minus 2x plus 5. Again, they gave us a quadratic function, not in vertex form. you can complete the square to get it in vertex form, or you can use this. I'm going to use this guy again. So let's do that. Or would you like to see completing the square? We'll just do completing the square. What is completing the square? You have to move C to the right-hand side. Well, we don't have a right-hand side. We just realized that's C. And divide both sides by A. Well, I can't divide out, so I'm going to factor out. I'm going to factor out a -1, leaving me with x squared plus 2x. And this is where I'm going to add my special term. I'm going to leave my plus 5. I didn't factor out a -1 from him, so he's going to stay there. All right, so if I add something special, since I'm working with one side of the equation, I also subtract something special from the same side. This is how completing the square would work. What is b? B is 2. b over 2, 2 over 2 is 1. I'm going to add 1 squared right here. Okay, so I added 1. Squared is 1. But really I added -1. So if I add a -1, I have to add a +1. So 1 minus 1 is 0. So I've really added 0. So I get here negative, factor this, x plus 1 squared plus 6. Now this is in vertex form. So you can do it that way, or if we had done it this way, h is negative b over 2a, just straight from here, we'd say -2 over 2 times -1 is a +2 over a -2 is a -1. And then that gave us the vertex, the h, right? And k comes from plugging in -1 here. So that's going to be -1 plus 2 is 1 plus 5 is 6. Here, vertex form, I'll say the vertex is -1, 6. It's negative, so it's facing down. So either way you want to do it, it's up to you. It's going to work out. Go find this guy, -1. 1, 2, 3, 4, 5, 6. Right here, he is facing down because negative. What is the axis of symmetry? X equals -1. The vertex is at -1, 6. Okay, what is the domain? What's the same domain that we've gotten every single time? Because it's a polynomial. The domain of all polynomials are -infinity to +infinity. Lines are polynomials. Their domain is -infinity to +infinity. The range, though, is depending on where the vertex is. It's from -infinity and whether it's facing up or down to 6 with the bracket. Equation of the line of symmetry, x is -1. Where is this guy increasing? He is increasing from -infinity to -1. He is decreasing from -1 to infinity. And this guy has a max value of 6. Okay, we're ready for the other side of the worksheet.